Hey y'all, it's Andrew Couch here, and you're watching the Tidy Tuesday web series, where each week I analyze a random dataset and try to teach you a data science technique. Before I start this week's dataset, which is about Australian pets, I wanted to say that I found that in my YouTube analytics that 53%, or the majority of you who are watching, are not subscribed. So I would recommend that you guys subscribe to me, so that way you can have a update whenever I publish my weekly video. So this is the Australian pets dataset. It comes with three different CSVs, one about animal outcomes, animal complaints, and Brisbane complaints. And one of you guys one of you guys said in the comments that you wanted to learn more about functions. So I thought this would be a good data set to try to teach you all about functions in the R and Tidyverse framework. So what we're going to do is open up a markdown. I'm going to call this Tidy Tuesday functions, and let's start this. Okay, so I'm going to remove that, load in the Tidyverse, and then paste this stuff in, and we'll run these code chunks using Control-Shift-Enter. Okay, so let's look at animal outcomes first. Just do a brief skim. Just shows year, animal type of animal outcome for each animal type, and then what that value is, and I guess in these regions. Pretty cool. Let's do animal complaints. Animal type, complaint type. Okay, not too interesting. If you notice that these columns might give us some problems. And then Brisbane complaints, not too exciting. I'm curious what these CSVs mean, but nothing too crazy. So let's look at animal complaints. If you notice, there's spaces in it. So if I say select animal type, it's going to give me an error. Instead, I'm going to actually have to wrap it around with quotes. So I think this will be a really good introductory area for how we can apply functions or learn how to use functions. Okay, so what is a function? A function just basically applies something to an input and then returns it. And in this case, actually R doesn't even have to require you to return a function. But I'm getting a little ahead of myself. So let's just create our first function. So I'm going to say my first function, and we'll say function, and we won't even give it an input. So a function framework is just, you have to write function, give it these little parentheses where you would put in an input, and then you wrap around these brackets. So in this case, I'm going to say print hello world, and this is our first function. So we got that, and we'll say my first function prints hello world. Okay, so how can we use functions with this data set? For example, right here, we want to change these column names. I want to change it to what is it? To like this, where everything's lowercase and it switches the space with a underscore. I'm fine with leaving ACT, NSW, and stuff like that because they're regions. And it seems like that's good distinction. I could also change total, but I'm kind of fine with leaving total as a capital. The big thing is to remove these spaces and switch them out with these underscores. Okay, so what I can do is I can use the rename all. What this does is we're going to rename all of the columns, and we can pass it a .funds, which is a function, and we can just specifically say function. But in this case, we need to give it a input, which we'll say .x, and that's kind of like the default thing. So your first input could be .x, your second input could be .y. If you're putting in just a data frame, it's good to just say df. So there's some naming conventions, but you kind of name it whatever you want. In this case, I'm going to name it .x because that'll represent each column name. So I'm going to use a pipe function too, and I'm going to say, okay, for all those column names, I want to convert it to a lowercase, and I also want to replace the space. So I'll say pattern equals space, and replacement is equal to underscore. And that's what it does. It lowered all of the column names and then replaced any spaces with a underscore. And what this function is called is a Lambda function or a helper function. So I'm going to say this like clean data using a helper / Lambda function. Cool. So one of the big ideas though is like, what is like, how does R play a role in this? Well, R is considered a functional programming language. So for example, if we look at like um, animal outcomes, outcomes, R is basically all functions. You don't really write anything else. So for example, mutate is a function, str is a function, print is a function. We're always using functions in R. So how can we apply a function that will start like manipulating data? Okay, so one thing that I was looking at right here is that all these regions are not in a percentage format or a decimal format. And I think that'd be kind of a helpful way to look at it, because I don't want to look at 610 and then look at the total. I think it'd just be easier to divide everything by total. And one way you could do this, right, is you could say, we could say like, okay, mutate ACT equals ACT divided by total, NSW equals NSW divided by total, and go on and on and on. That's not a very smart way to do it. Hadley Wickham says that if you're basically repeating a function or something like more than 10 times, then you should probably pass it into a function. So that's what we're going to do. And in this case, I'm going to say convert to like decimal, right? And we're going to give it a function. And we have to kind of think about, okay, what inputs do we need for a function to convert something to a decimal place? Well, first we probably want the value that we want to convert that value into a decimal, and also the total, right? Because we need to divide, this value divided by the total. And then what we can do is we can do return, and we say value divided by total, right? Pretty straightforward. But that still doesn't really help us, right? If you think about it, value divided by total, because if we still do this, if we say, okay, well, it's not really helping me, because then I still have to repeat. So like nt equals convert to decimal, nt, and total, right? Not really great, because that means I still have to repeat it. Luckily, R actually has a little helper function for you to apply a function on all of the columns. And what that function is called is the across function. So what we're going to say is we're going to say mutate, and we're going to say across. And for across, we have to give it the columns we want to apply a function to. So in this case, we want to apply it to ACT to WA. And I'm going to say across right here. And what else we have to give it is a .fns, which is a little bit different than .funds, but they're the same thing. They're just saying we want a function. One thing with across is you actually give it the function inside of across, and then across will act as the function in the mutate. Okay, so it gets kind of confusing, because like usually when you do use mutate, you put the function outside of it, right there. So it's like, okay, across these variables, I want to apply this function, but across, you have to give it everything in there and just put it into a mutate. So we're gonna give it a tilde for the function, and then we'll say convert to decimal, value equals .x. In this case, .x will represent all of these columns, and then our total will equal to total. And what that do? It applied this convert to decimal function to all of the rows or all the columns that we wanted to. Right? So that's a pretty good way to do it. So let's say like apply function across columns using across. But if you look at this is kind of a confusing thing to look at. You're like, well, what are we looking at here? Like this seems kind of weird. We can also just make this right here into a function. So let's say convert area to decimal, right? And we can give it a function. In this case, we're gonna make this pipeable. So we'll say create a function that is pipeable, that does the same thing. So when we're piping, it's always saying like, we're gonna pass this value into here, and then you're gonna return whatever is coming in, whatever you did, into the next value. So then that means we're just gonna pass it into a data frame. right? And what we can do then is we can just give it, right, our data frame, and then we can just give it the with the mutate across, right? And this, if you think about it, this is actually just using convert to decimal function right here. So you could always put this function inside of here, right? So if we do that, we can do this: animal outcomes convert area to decimal, and does the same thing, but it's a little cleaner, right? So this thing looks cleaner and does the same thing, right? This looks cleaner because if you're seeing someone do this, you might not be familiar with R, but right here we know what it's doing. It's converting area to decimal. Cool. And what's kind of cool about this is there's actually other ways to create functions. So we can say another way to create the same function. And I actually learned this. I actually learned this from David Robinson. So I can say tidy area %, right? And what we can do is we can just pass this thing right here, but switch the df into a dot. And we can do that. And if we try this again, animal outcomes tidy area %, and it does the same thing, right? So that's pretty cool. And right now, like all these things were these, I guess, like three main functions of like helper functions, basic functions, and then using the functions to do across different variables is pretty useful. And it's kind of, that'll get you basically 80% of the way there. But sometimes you might want to be able to specifically specify a column or write out the column that you want to apply the specific function to. For example, like whenever we're doing like, let's see here, animal outcomes. Say, for example, I want to just say like select like outcome, count outcome, and then just do a ggplot. AS x equals outcome, y equals n. Create a column, and then do a chord flip. Select. Right. This is a pretty standard chart that I always make. And we can also say like we can do like a mutate maybe. So like mutate outcome equals reorder outcome by n, and boom. Right, this is a pretty straightforward chart, and I always make them. But what if I want to say, instead of using outcome, I want to select animal type, right? So that way I'll have to copy this, replace all that. It probably makes more sense to make into a function, and that's where tidy eval goes into it. Or tidy eval, where it creates functions where it say like, okay, I want you to do this type of manipulation on a specific column that I state. So that's what we're gonna do. We're gonna say create the create bar chart, right? And say function, and we have to give it something. First, we have to give it a data set, and we also give it an outcome, right? Or give it a variable that we want to select. So I'm going to say column var and a data frame. Since column var is essentially going to be like this select, it's going to be a string. So what I can say for I guess R to really understand that you're going to be stating this variable and using it as like almost a name, we're going to assign it again to this other thing, which is called the nquel column var. And this basically, it's for what the user, it's for the function to understand that the user is going to be typing this. Okay, boom. I'm going to clean this a little bit. Okay, so we're going to switch this data frame into that. And we're also going to give this column var into it. Okay, so outcome, was it column var, column var, column var, and that's it, right? Should be pretty easy. But if we actually do it, we might run into a problem. Let's say outcome, and then we give it animal outcomes. It runs into an error because it doesn't understand it, right? And that's why you have to add in these things, which is called a bang bang. Okay. And when you're doing assigning something to a bang bang, you also have to add a little colon behind it. So once you do that, so we have to say must add bang bang. Also use instead of for bang bang, right? And this stuff, you just kind of have to know it. There's definitely some computer science into it, but to be honest, I don't really know a lot about it. And I think it's really out of the scope. If you do want to learn it, I think there is a nice advanced R for data science textbook that you can read and really understand how this works and stuff like that. Okay. So let's see here. Okay. AS X equals. Cool. So let's see here. We have outcome right there and it's doing that. What's going on here? Maybe, in fact, you know what? Maybe I'll just remove that and see how it works right here. Interesting. Okay. Oh, that's why. Outcome. There we go. Sorry, I didn't want to pass it in a string. So, yeah, you can just say like outcome. Sorry, I was looking at it, I was wondering why it wasn't doing what I wanted to do because I had it into a string. So yeah, there you go. We have outcome. Right. If we want to do something else, say like animal type, it is animal type. So that's pretty useful, right? Also I can, obviously do like, I don't know, what is it? Maybe minus n, and also do like fill equals column var, and do that, and then we can kind of see a nice little chart right there. Actually, maybe I'll just do a regular n. Okay, and maybe I'll do a theme legend dot position equals none. Cool. Looks pretty cool. Switch it, and it does the same thing, and it's pretty easy to do it. So sometimes, if I showed you right here, this function, it's not really returning anything, it's just printing something. And that's where we can do functions that really aren't going to be returning stuff. Instead, they're actually just going to do specific things in the background. And where's this useful is it's kind of useful for like automating saving or batch saving. One thing that I would say is like, oh, what if you're subsetting a lot of like real estate data and you want to send these CSVs to each state or city. You wouldn't want to just kind of go line by line, save, rename, and go through like 100 cities. That would take like 2 hours, and you'd be wasting your time. Okay, so let's figure out a way to do this. Okay, and I think Brisbane Complaints looks really good about this. For example, we have this. What type of charts would we want to see? First of all, I think we could make something with the suburbs, right? So let's just say filter suburb is equal to, I don't know, Sunny Bank. And then how about we just say, I don't know, let's just count the amount of issues. That seems like a pretty reasonable thing. Or count category, right? So count the categories of stuff that we want to kind of look at. What else could we do? Yeah, I think that's kind of a useful thing. So if you do like a mutate category reorder category by n ggplot as x equals category y equals n geom column plus chord flip plus theme legend dot position equals none. And then what else we could do? Oh, and then we say, like, I don't know, fill equals category. Right, so that's pretty good plot maybe we want to do a drop NA. So drop NA. Oops, drop NA. And then, yeah, that seems pretty useful. So this is a chart purely for Sunnybank, okay? What if we wanted to do this to all of the suburbs? We wanted to say, okay, guys, here's what's happening in your suburb. Here are the main types of category issues that we've found. Ooh, actually, now that I look at it, what if we want to say filter animal type by, also we'll say animal type is equal to attack. How many animal attacks are we experiencing, right? So attack on person, attack on animal, not an attack, menacing. I think that's something that a neighborhood would really want or a suburb would really want. But if we want to create this for each suburb and kind of save it as a PDF and send it to them, it could get it could take a long time, especially if we look at how many suburbs there are, right? So there's about 192 suburbs. That's almost too many suburbs, right? So how can we do this? How we can do this is we can just kind of make a function for this. So let's create a function for it. So let's say make a function that creates a chart for each suburb and saves it as a PDF, right? So let's do it. Let's say save charts, and we'll give it a function. We'll give it a data frame and a file name. And here's what I think we could do for this. For example, let's say filter right here. So we have that. Let's count the categories for each. So we can say count categories for each suburb. Count the categories, right? Right? Cool. And that's fine. And then we can just drop NAs. So right here is what we kind of want, right? And then what we can do is we can do a nest minus suburb, right? And now what we have is kind of like a suburb, or like what we want to call the PDF. And then we have our data, which is what we want to put into our actual chart. Okay, cool. So that's what we're going to do. We're going to give this and throw it in here. So we'll say df and mutate it and do all of this. Okay, and I'm going to clean this up a little bit. There is definitely a fast way to do this, but I'm going to also do this while I think. And what we're going to do is we're going to give this to a chart. We'll say chart. We'll say temporary chart. We'll give that. And then what we'll do is we'll just say, like, I don't know, maybe we'll do like plus GG title, and we'll say like paste 0, file name, and then say attacks, right? So what we want to do is also save it. So we'll just say GG save, file name is equal to paste 0, file name dot PDF, plot equals temp chart, width equals 11, height equals 8.5, units equals inch. So what I want to do is basically that chart that I created, I want to save it into a PDF named after that neighborhood. And it'll be an 8.5 by 11 PDF. That's gonna be a cool looking chart. Okay, that's pretty useful. What else am I doing? So if we look at this function, if you think about it, it's not really returning anything, right? It's just saving. So that, and if you use other functions such as map, let's see here. Let's go back here. Why is it taking? If we use some functions like map, it's actually going to want something to be returned. Instead, what we're going to have to do is use the function walk. Okay. And in this case, we're actually going to use walk too, because we have two inputs. I also want to do a mutate suburb is equal to str replace, and then we'll say suburb pattern and then replacement, just because you can see how there's I want to add an underscore to it. Okay. Cool. And now what we're going to do is I'm actually going to make sure that so I'm going to set as working directory, and then I'll do the RStudio editor. And then what we're going to do is we're going to do the walk2. We'll give it our data, which is our input, which is our df, our suburb, and we'll give it our save charts function. Not found. So a common thing with it is like R not really understanding what's a variable and what's like a random argument. So what I recommend is loading up the migrator package. And what's cool about that is it's already included. They basically have, they're the ones that create the pipes, but they also come with other pipes, which allows you to use this pipe, which basically kind of helps the walk function discern what are the names or the columns you want to select. So we're going to do that instead. And let's see what it's doing. It's going to save all of these files into a PDF, all 113 of them. Okay, so we're going to let that go. Obviously, I'm going to remove a lot of the PDFs so I don't commit it. But let's check our actual repo. So I'm going to load up the Tidy Tuesday, and let's see what's going on here. And we can see all of these PDFs that were saved, right? Look at those PDFs. Let's open one up. We can see that Windsor attack on a person. Let's open up, say, Sunnybank. You can see how they're different, right? Sunnybank. Let's see. Look at Norman Park. Okay, so you can see how this is a pretty useful thing, right? You can see how like, oh wow, like if I have a lot of these reports or CSVs that that I need to send out every week, I can use these functions to basically do these batch saving and basically do all the legwork for me. That's basically it. I know I went pretty fast with it, but the main idea is functions are all about doing the main legwork that you don't want to do. You know, it's good for repeating things. It's good for cleaning up your code to make it look simpler, and it's good for doing batch jobs. Not all functions require an actual input, and not all functions require an actual output. And what's necessary about it is if the function doesn't require an output, you always have to use walk. If it requires an output, then you have to use map. So that's it. I'll see you guys next week, and tidy on.